Hello, so we need to be able to be comfortable with the idea that if we have two graphs, let's say we have a straight line and a curve, their point of intersection means that we solve them simultaneously. So the two equations, the curve and the line, we set them equal to each other. Okay, so that's the interpretation of simultaneous equations. So in this example, we've got the line y is 2x add 1 and the curve kx squared add 2y add k minus 2 equals 0. So the curve and the line intersect at one point. So we need to solve them simultaneously, meaning we set them equal to each other. So we have y is 2x plus 1. I can substitute that. So I can sub y into the other equation. If I call this equation 1 and equation 2. So that means that then kx squared add 2y, which is 2x add 1, add k minus 2 equals 0. Then if I expand that, I get kx squared add 4x add k equals 0. Okay. And then if there's one point of intersection, 1 point, that means it's one real root, which means the discriminant is equal to 0. Which therefore means the discriminant is going to be 4 squared, take away 4 lots of k, equals 0. So then 16 take away 4k squared equals 0. Therefore k squared is 4, so k is plus or minus 2. But we're told that k is positive, so that means k is equal to 2. There we are. Then it says, for this value of k, find the coordinates of the point of intersection. In other words, the solution to the simultaneous equations. So if k is equal to 2, then we get that the this quadratic here boils down to 2x squared add 4x add 2 equals 0. Then we can divide by 2 to get x squared add 2x add 1 equal to 0. Then that factorizes to x plus 1 equals 0. So the only solution, because it's x plus 1 squared, effectively, it's the same bracket, we get x is equal to minus 1. So the corresponding y value then, well, we know that y is equal to 2x plus 1. So if I sub that in, then I get that y is going to be 2 of minus 1 add 1. That would be minus 1. So my point is going to be x is minus 1, y is minus 1. And that's my point. Okay, we've got this example, and we're given a swimmer that dives, and the swimmer's position is this curve here. That curve's not sketched, but it would look something like this. So we need to know if it's above, if it touches the base of the pool, which is this equation here, drawn there, or does it go beneath, and then it'll cross the pool. How do we determine that? So we can set them equal to each other, because they're both positions, right? So that means p is a half x squared minus 3x, and then also p is 0.3x minus 6. So we want to see if ever the swimmer's position crosses the position of the base of the pool. So we set them equal to each other. So a half x squared minus 3x equals 0.3 minus x minus 6. So then if we do a half x squared, then take away 3.3x, add 6 equal to 0. We can test if there are any solutions by doing the discriminant. So b squared minus 4ac would equal minus 3.3 all squared. Take away 4 lots of a half, lots of 6. And that would be negative 1.11. So that's negative. So there are no real solutions, no real roots. Which means that therefore the swimmer never reaches base of the pool, or the bottom of the pool.